told you I would find it, and I found it. Okay, so made a crucial mistake, and it was right here. So this, you can use this angle, okay, to define theta. You can use that angle to define theta, no problem. But what happens is that you can't use the vertical angle theorem. So this angle is not theta anymore. These two angles no longer are theta. What happens is this. This angle and this angle are complementary, okay? So if you label this angle as phi, but this angle and this angle are also complementary, so this is theta, so this angle is now phi. So, yeah, this angle would be phi. So this angle is now theta. That angle is now theta. So cos of theta is not z over r, it's a over r. And that was the part that was bugging me, and that was the part that was the mistake. So this is a over r. So this was a over a squared plus z squared to the 1/2. Now this is still correct. So this just goes to mu naught a squared. That was the part that was getting me. But yes, and this is correct. And the reason that it wasn't feeling right was because the formula that I'd written down gives you a value for a magnetic field of 0 when you go down to the middle of the ring, and that's not the way it works. So we know that there's a value of a magnetic field at the center of this ring. The magnetic field does not go to 0 the same way that the the electric field of a charged ring goes to 0. So, but that is correct, and it was from this. And what's really going on here is this. If you have a ring whose radius is the same as your height, then this vector r and this dB, remember this dB contribution was from this dl, okay? This dB contribution was from this dl, not this dl. So this is not like the electric field that just goes up and then keeps going. So this contribution actually says nothing about this vector right here. So you cannot automatically assume these angles are complementary. If you have a really narrow ring and you're measuring it a very long distance above the axis, then your vectors are very much not going to be in line with each other. Okay, but the way my drawing worked out is that this vector is almost in line with that vector, and I accidentally made the mistake of using vertical angle theorem, but you can't do that here, okay? What you have to do is say, okay, this angle, and then look at this angle, and then look at that angle, and then look at that angle, and then find that one. That's the proper way to do it, okay? So there you have it, the correct derivation of the Biot-Savart law for a charged ring. So I hope that the previous video was helpful in setting it up, and this video was helpful in solving it and correcting any misconceptions. And that, I think, does it for the Biot-Savart law, and in the next set of videos we will look at Ampere's law. All right, take care, everybody.